We have question 3 from a November 2021 exam paper. Now, question 3 states, in the diagram, A, B, and C are vertices of triangle A, B, and C. Vertices meaning the corners, the 3 points of the triangle. Line BC is produced to H, meaning that BC is extended to the point H and cuts the x-axis at E. So E is the x-intercept of the line BCEH. AB and AC intersect the x-axis at F. So that means that the line AC and AB intersect the x-axis, meaning that it cuts the x-axis at F and G. So those are the x-intercepts. The angle of inclination of the line AB is 81.87 degrees. So the angle of inclination, meaning from the x-axis to that line, so this is the angle of inclination, is 81.87 degrees. Our first question, 3.1, calculate the gradient of BE. In order to calculate the gradient of the line BE, we need two known points on the line BE. We can use the coordinates of C and the coordinates of E as both are known. So here we're going to use the coordinates of C, which are 4 and -2. And the coordinates of E, which are 12 and 0. Keep in mind, this is question 3.1.1. We need to calculate the gradient. So we are going to use our gradient formula, which is the change in y over the change in x. I'm going to make C my x1 and y1 coordinate, and E my x2 and y2 coordinate. From here we can substitute. So this is going to be 0 minus -2 all over 12 minus 4. We can put this into our calculator, and we therefore have the gradient of BE as equal to 1 over 4. So that is it. In order to calculate the gradient of a line, you require 2 points on that line. Use your gradient formula, substitute into your gradient formula, and you are done. Question 3.1.2, calculate the gradient of AB. Now, to calculate the gradient of AB, as you can see, we do not have 2 points on the line AB. Both F and B are unknown. However, we have the angle of inclination of the line AB. So we can determine the gradient of the line AB using the angle of inclination of the line AB. So our theta value is 81.87. So our formula is gradient equals tan theta, whereby theta represents the angle of inclination of the line. We're going to substitute our value of theta. From here, we can put this into our calculator, and we therefore have the gradient of the line AB as equal to 7. And that is it. Our next question, question 3.2, determine the equation of BE in the form y equals mx plus c. So please keep in mind that we already have the gradient of the line BE. So in order to calculate the equation of the line BE, we need the value of c, the y-intercept. Please do not confuse the point C with the value of C. When I say C, I'm referring to the y-intercept C, the point at which the line cuts the y-axis. So to determine the value of C, the y-intercept, we are going to use one of the coordinates as well as the gradient, substitute it into the equation of a line, and then solve for C, this little c over here. Now you can use the coordinate c or you could use the coordinate e, it's up to you. I'm going to use the coordinate e, which is 12 and 0. So this is question 3.2. So my coordinate e is 12 and 0. I'm going to make this my x and y. We know that the gradient of BE is 1 over 4. So our formula for the straight line, or you could say for the equation of a straight line, is y equals mx plus c. From here we are going to substitute 0 in place of y, 1 over 4 in place of gradient, and 12 in place of x. A quarter times 12 is 3. From here, we now know that c is equal to negative 3, the y-intercept. Now, we are going to substitute m and c into the equation of a straight line. And we therefore have the equation of the line BE as equal to 1 over 4 x minus 3. And that is it. That is the equation of the straight line BE. All you needed to do was identify the gradient, calculate the c value, the y-intercept, using one of the coordinates, and substitute m and c back into the original equation of a straight line, and you were done. If we used the coordinate point C, which has coordinates 4 and negative 2, we would have ended up with the exact same values. Let us make a note that this is negative 3. Our next question, 3.3, calculate the coordinates of B where k is less than 0, meaning that k is negative. So please keep in mind that the coordinates of B have the same x and y value and they are both negative. The reason we know that they have the same x and y value is because both are k. Now, from here, in order to calculate the coordinate B, we have the gradient of the line AB. So using that point A, we can determine the equation of the line AB. We already have the equation of the line BE. So once we have the equation of AB and BE, we can determine B, the point of intersection of the two lines, by solving for x and y simultaneously. So step number 1, let us determine the equation of the line AB. we calculated the gradient of the line AB as 7. In order to determine the value of C, the y-intercept of the line AB, we need a coordinate on the line AB. We're going to make use of the coordinate A, which is -2 and 10. So will be our x value and our y value. So we can substitute into the equation of the straight line. If we move -14 to the left, it's going to become +14. So we therefore have C as equal to 10 plus 14, which is 24. So let us go and make a note. Our value of C is 24. Okay, as you can see, the y-intercept of AB is not on the diagram, so we don't need to make a note. Now that we have the equation of AB, let us actually just finish up the equation quickly. Now that we have the equation of AB and we have the equation of BE, we can solve for B using simultaneous equations. So we can state the equation of AB, which is 7x plus 24, is equal to the equation of BE, which is 1 over 4x minus 3. From here, we are going to solve for x. So we're going to take a quarter x to the left. So 7x minus a quarter x is equal to -3 minus 24. On the right, this gives us -27. On the left, 7 minus 1 over 4, and that is equal to 27 over 4x. We're going to divide both sides by 27 over 4, or you could say we're going to divide both sides by the coefficient of x, and we therefore have x as equal to -4. Now keep in mind the x value of b was known as k, and both the y and x value was equal to k, which means k is therefore equal to -4. So we now have the coordinate of b, which is k and k, as equal to -4 and -4. So that is the B coordinate. We used the point of intersection method by taking the equation of the line AB and the equation of the line BE, since B is a common point on both lines, and solving for x and y simultaneously. Because k is both the x and y value, once you found the x value, you automatically had the y value. Our next question is 3.3.2. Calculate the size of A. Now, if you notice, A is this angle over here. Now, another thing to take note of is you have the angle at F. You're looking for the angle at A. If you take the triangle AFG, please take note that the exterior angle AG and let's call it E. So let's extend this line to the point E. So this exterior angle AGE, which is this angle over here, is equal to the sum of the opposite two interior angles, A plus F. So if we are able to find the angle of inclination of the line AG, we can state that the angle of inclination of the line AG is equal to the angle A plus the angle at F, which is 81.87. So our first order of business is to calculate the angle of inclination of the line AG. In order to calculate the angle of inclination of the line AG, we need to determine its gradient. To find gradient, we need 2 points on the line AG. Now, as you can see, AG is extended to C, which means C is a point on the line AG. So if we calculate the gradient of AC, that is going to be the gradient of AG. So let us start by calculating the gradient of AC. So this is question 3.3.2. We are going to use the coordinates of A, which is -2 and 10, and the coordinates of C, which are 4 and -2. A will be our x1 and y1, C will be our x2 and y2. So to calculate the gradient of the line AG, we are using the coordinates of A and C. Once you put this into your calculator, you'll then end up with the gradient of AG as equal to -2. Now that you have the gradient of AG, you can determine the angle of inclination of the line AG. So here, the formula that we are going to use is M equals tan theta, whereby M, which is our gradient, is equal to -2. We're going to substitute the gradient and then solve for theta. Please keep in mind that because our gradient is a negative, we're going to plus 180. Once we put this into our calculator, we therefore have the angle of inclination of the line AG as equal to 116.57. Now, I'm going to draw a quick sketch. So, this top point here, this is A, which has coordinates -2 and 10. This is F. The angle at F is 81.87. Let's just extend this arc a bit. That should be fine. Then we just determined the angle of inclination of the line AG as equal to 116.57. So we have the angle of inclination of AF as well as the angle of inclination of AG. To determine the angle at A, we are going to state that the angle A plus the angle F is equal to the angle AGE. And our reason for this, so let's just bring this down here where we have more space. Our reason for this is the exterior angle of the triangle is equal to the sum of the opposite two interior angles. So from here we can substitute F as 81.87. We can substitute AGE as 116.57 and put this into our calculator. We therefore have A as equal to 116.57 minus 81.87, and our answer is therefore equal to 34.7 degrees. So that is the angle A. Keep in mind, an alternative would have been to use angles on a straight line and calculate this angle that I've arced in purple. Then use the sum of three interior angles of a triangle. That would have been an alternative method. So that is question 3.3.2. Next we have question 3.3.3. Calculate the coordinates of the point of intersection of the diagonals of parallelogram ACES, where S is a point in the first quadrant. Now, keep in mind that the diagonals of a parallelogram bisect at the point of intersection, meaning that where they intersect, that is the midpoint of the diagonals. So if we were to sketch this parallelogram ACE, I'll show you now on the Cartesian plane that was provided. So if we were to sketch it, it's ACE, and then S is in the first quadrant, so it'll be here. So that will be the parallelogram. Now keep in mind the diagonals of the parallelogram, they bisect at the midpoint. So that means that A, let's call this point here M. So AM is equal to ME and SM is equal to MC. That means if we want to find the point of intersection of the two diagonals, we can use the midpoint formula and we can use the coordinates A and E. So let us get started. So this is a much better sketch. I'm going to call this point M as mentioned earlier. Now we are going to determine the coordinates of M. M is the midpoint of the line AE and the line SC. Because I only have the coordinates A and E, I do not have the coordinates S to use SC. So I'm going to use A and E. So my midpoint formula, let's write it down. Let's substitute. So I'm going to make A my x1 and y1, C, or rather E, my x2 and y2. So it's going to be negative 2 plus 12 all over 2 and 10 plus 0 all over 2. We can put this into our calculator, and we therefore have the midpoint coordinates as 5 and 5, meaning that the point of intersection of the two diagonals of this parallelogram are 5 and 5. So if you did not know the properties of a parallelogram, it would have been difficult to solve for this question. Next, we have question 3.4.1, another point T, which has coordinates P and P. So please keep in mind that T has its X and Y value as the same thing. If its X value is 10, its Y value would also be 10, since it's P and P, where P is positive. So keep in mind that because both X and Y are positive, it means that T is in the first quadrant, is plotted such that ET is equal to BE is equal to 4 the root of 17 units. So ET is equal to BE. So if we were to draw a random line and call this T, which has coordinates P and P, take note that ET is equal to BE. So the length of BE is equal to the length of ET. And they stated that length was 4 the root of 17 units. Now, the question states, calculate the coordinates of T. In order for us to find the coordinates of T, we already know what the length is, so we can just use our distance formula. We're going to use the coordinates of T and the coordinates of E. So let us get started. This is 3.4.1. The coordinates of T are P and P. The coordinates of E are 12 and 0. Going to make this my x1 and y1 and x2 and y2. From here, our distance formula is d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. We can substitute. Keep in mind this is the distance ET. So that is going to be P minus 12 squared plus P minus 0 squared. ET is 4 the root of 17, and that is equal to the square root of P minus 12 squared. We can actually expand that and make it P squared minus 24P plus 144 plus P squared. So we use our FOIL method on the first bracket. P minus 0 is just P, square that is P squared. From here, we are going to add up the like terms under the square root and then square both sides in order to get rid of that square root. So if we were to square both sides, the square root on the right would disappear. For the left-hand side, for the square root of 17 all squared is equal to 272. And that is equal to, so here we're going to add the like terms, p squared and positive p squared. That is going to give us positive 2p squared. Then we just bring down the remainder, which is negative 24p plus 144. From here, we're going to move everything to one side, as this is a quadratic equation. As you can see, 2 is a common factor, so we can divide the left and right by 2, giving us p squared minus 12p minus 64 is equal to 0. From here, we can factorize. This is going to give us p minus 16 and p plus 4. You can also use your quadratic formula if you want to, or you can use completing of squares, whichever would be fine. And we therefore have p as equal to 16 or p as equal to negative 4. Keep in mind it was stated that p has to be greater than 0, meaning that p has to be positive. So we now know that p is equal to 16, not negative 4. So we can therefore state that the coordinate of t, which is p and p, is equal to positive 16 and positive 16. So that is it. Next, let us have a look at question 3.4.2. We need to determine the equation of the circle with center at E and passing through B and T in the form x minus a all squared plus y minus b all squared equals r squared. So we need to determine the equation of the circle at E, and it's passing through B and T. Let's see. The circle is at E, meaning that the center of the circle is the point E, and it's passing through B and T. So B and T are points on the edge of the circle, or you could say the circumference of the circle. So if we were to draw this circle, let's actually attempt that. So this is our circle. This is the center of our circle, E, which has coordinates 12 and 0. And we have T, which has coordinates 16 and 16, as well as B, which has coordinates negative 4 and negative 4. Now, if you want to determine the equation of a circle, please keep in mind you need the center points, or you could say center point, which is E. So our A value is 12, our B value is 0. Then we need the radius of the circle. So please keep in mind the radius is from the center to the circumference. So to determine the radius of the circle, you can use E and T, or you could use E and B. Please keep in mind we already know the length ET. The length ET is 4 the root of 17. So here, let us just make a note. ET is 4 the root of 17. Now the equation of a circle is x minus a all squared plus y minus b all squared equals r squared. We know that the radius is ET. So we're going to substitute the value of a, which is 12. So that is going to become x minus 12 all squared plus our value of b, which is 0, and r, which is 4 the root of 17 squared. From here, that is going to become x minus 12 all squared plus y squared is equal to 272. And that is it. That is the equation of the circle at E. Keep in mind, whatever comes after the word at is your center point. So this is the equation of the circle at E, and the circle passes through the points B and T. Passes through, meaning that those points are on the circumference of the circle. So if you want to determine the radius of the circle, you take from the center to one of the points on the circumference. So that is it. Next, let us have a look at B. Question B. Question B states, determine the equation of the tangent to the circle at B. So if we need to determine the equation of the tangent to the circle, let us draw a quick tangent. So this is the tangent line. Please keep in mind that a tangent is perpendicular to the radius. So if we were to find the gradient of the radius, the gradient of EB, we will then be able to determine the gradient of the tangent. So let us start by finding the gradient of EB. So to find the gradient of EB, we are going to use the coordinates E, which are 12 and 0, and B, which are -4 and -4. From here, the gradient formula we can substitute into this gradient formula, and we therefore have the gradient of EB as equal to 1/4. Now that we have the gradient of EB, we can determine the gradient of the tangent, because we know that a tangent is perpendicular to the radius of the circle. So we substitute the gradient of the radius and then solve for the gradient of the tangent. So we therefore have the gradient of the tangent as equal to -4. Now that we have the gradient of the tangent, we can use the equation of a straight line, because keep in mind a tangent is a straight line. So we have the gradient, that's -4. We need a coordinate on the tangent. B is a point on the tangent, so we're going to use B, which is -4 and -4. From here, that is going to become -4 equals negative 4 into negative 4 plus c. This is going to become minus 4 equals 16 plus c. Take 16 to the other side. It's going to become negative 4 minus 16. And c is therefore equal to negative 20. From here, we can substitute into the equation of a straight line. So y equals negative 4x minus 20. This is the equation of the tangent. And that is it. Always remember from Euclidean geometry that a radius is perpendicular to a tangent. So in order to calculate the equation of this tangent, all we needed to do determine the gradient of the radius EB. Once we had the gradient of the radius EB, we could determine the gradient of the tangent because the tangent is perpendicular to the radius. Once we had the gradient of the tangent, we needed a coordinate on the tangent, that being the point B, to determine the C value, the y-intercept. Once we had C and our gradient, all we needed to do was substitute M and C into the equation of a straight line, and we then had the equation of the tangent. Next, we have question 4. Keep in mind, question 4 is also from a November 2021 exam paper. Now, question 4 states, in the diagram, the circle centered at N passes through A and C. That means A and C are both points on the circumference of the circle. B, C, D, and E are joined to form a parallelogram. Please keep in mind that the properties of a parallelogram are that opposite sides are parallel and opposite sides are equal. The diagonals bisect each other, meaning that they meet at the midpoint to form a parallelogram such that BE is parallel to the x-axis. So if BE is parallel to the x-axis, and we know that BE is parallel to CD, that means that CD is also parallel to the x-axis, meaning that CD is a perfectly horizontal line. Now, something important to take note of is that the y value of C is going to be the same y value as D, and the y value of B is going to be the same y value as E. Let us actually make a note of that. So the y value of C is equal to the y value of D, and the y value of B is equal to the y value of E, which is equal to 2. Now, let us continue. So it states, CD is a tangent to the circle at C, and CD is 6 units. Now, if CD is 6 units, we know that opposite sides of a parallelogram are equal. That means that BE is also 6 units. So let's make a note of this. CD is equal to BE is equal to 6 units. Now, if BE is 6 units, that means E is 6 units away from B. So if we add 6 to negative 4, that is going to give us the x value of E. So negative 4 plus 6 is going to give us positive 2. So here we can determine the x value of E by taking the x value of B and adding 6 units. So we therefore know that the coordinate of E is therefore going to be positive 2 and positive 2. Now, let us continue. So here, question 4.1, write down the length of the radius of the circle. So we need to determine the length of the radius of the circle. Now, something very important to take note of is that the x value of n is equal to the x value of a. So this is a vertical line, meaning that it is parallel to the y-axis. Now, if we want to determine the radius of the circle, we are going to use this vertical line. We're going to say the top y value minus the bottom y value. 3 minus negative 1, which then means the radius of the circle is 4 units. Alternatively, you could have just used your distance formula using the point N and A. So here, to determine the radius of the circle, this is question 4.1. We're going to use N, which is negative 1 and negative 3, as well as A, which is negative 1 and negative 1. So to determine the radius, we are going to determine the change in height. That is going to be, let me just confirm the coordinate of n. It is positive 3, not negative 3. So let us change this. It is positive 3. So to determine the radius, which is the height of NA, we're going to take the top y value minus the bottom y value. So 3 minus negative 1, and we therefore have the radius of the circle as 4 units. And that was 1 mark. Next, we have question 4.2. Now, question 4.2 states, calculate the coordinates of C. Now, if you notice, C is directly above N, which means that C is going to have the same x value as N, meaning that it is going to have an x value of negative 1. But what is the y value? If you are at N, keep in mind the radius is 4. So if you are at level 3 and you jump 4 steps up, or you move 4 steps up, you're then going to be at 7. So to find the y value of C, you just take 3, add the radius, and that is going to give you the y value of C. So here, our coordinates of C is just negative 1 and 7. So here we can make a note that the x value of N is equal to the x value of C, which is negative 1. To find the y value of C, you take the y value of N and you add the radius, which is going to give you 3 plus 4, and that gives you 7. Therefore, the coordinates of C are negative 1 and 7. Next, we have question 4.2.2. Now, question 4.2.2 states, calculate the coordinates of D. Now, we've already discussed that D has the same y value as C, because CD is parallel to BE, is parallel to the x-axis. So we know that the y value of C is equal to the y value of D, which is equal to 7. Now we need to determine the x value. We know the length CD is 6 units. That means that D is 6 units away from C. So if you start at C, which has an x value of -1, and you move 6 units to the right, that means take -1, add 6, and that is going to give you your x value of D. So the x value of C plus the length of 6, that is going to give you the x value of D. So that is going to be -1 plus 6, and that is going to give you 5. So we can therefore state that the coordinates of D are 5 and 7. So that is it. Next, let us have a look at question 4.3.1. Actually, we jumped one. We have 4.2.3 first. So 4.2.3, calculate the area of triangle BCD. So triangle BCD. This is the triangle BCD. If we want to determine the area of the triangle, we are going to need the base and the perpendicular height. So let us just do a quick rough sketch of that triangle so that you can see the perpendicular height. Now, the base is CD. The perpendicular height is this dotted purple line. That is the perpendicular height of this triangle. If you want to determine the height, you can see that the top, let me highlight it for you, this part here, CD, that has a height of 7, and the lowest point, which is B, has a height of 2. The height of this triangle is 7 minus 2, the top y value minus the bottom y value. So our perpendicular height is 5 units. Now that we have the perpendicular height and we have the base, which is 6 units, we can determine the area. We know that our area is equal to a half base times height. Our area is then equal to a half. The base is 6. The height is 5. We can put this into our calculator, and we therefore have the area of the triangle BCD as equal to 15 units squared. So that is it. Always remember, when calculating the area of a triangle, you need the perpendicular height as well as the base. An alternative approach would have been to use angles of inclination to determine this angle here by C. Then use your formula, a half times BC times CD times the angle, or you could say times sine of the angle C. And that would have also given you your area. So that is question 4.2.3. Next, let us have a look at question 4.3.1. Question 4.3.1 states, the circle centered at N is reflected about the line y equals x. M is the center of the new circle which is formed. The two circles intersect at A and F. So please keep in mind that when something is reflected about the line y equals x, it means that the x and y values are swapped. Or you could say interchanged. If you remember from functions and inverse, to inverse a function, you reflect it about the line y equals x and you swap the coordinates. So here The first question, calculate the length of MN. So if we want to find the length MN, we need to determine the coordinates of M because we already have N, it is -1 and 3. So we need to determine the coordinates of M, which is the center of the reflected circle. Now, if you remember, I stated to find the coordinates of a function that has been reflected about the line y equals x, you swap the x and y value. So to find the coordinate of M, you are going to swap the x and y value of N. So the coordinate of M is going to be 3 and -1. You swap the x and y value of N. So let us just make a note of this. So the coordinates of M are 3 and -1. Now that we have the coordinate of M, we can determine the distance MN. So to find the distance MN, we are going to use our distance formula. We're going to use the coordinate N, which is -1 and 3, and M, which is 3 and -1. This is going to be x1 and y1, x2 and y2. From here, we can substitute. We can put this into our calculator, and we therefore have the length MN as equal to 4 the root of 2 units. So please keep in mind the distance between the two circles is 4 the root of 2 units. In order to determine the length MN, all we needed to do was determine the coordinate of M, then use our distance formula and substitute the points M and N. Lastly, let us have a look at question 4.3.2. Question 4.3.2, calculate the midpoint of AF. So please keep in mind, in order to calculate the midpoint of AF, we need the coordinates of A and F. So let's go back. On our diagram, we have the coordinate of A. However, we do not have the coordinate of F. So let's have a look. It is stated that the circle centered at N is reflected about the line y equals x. M is the center of the new circle which is formed. The two circles intersect at A and F. So please keep in mind A and F is the point of intersection of the two circles. So here, let's see. if we were to sketch these two circles, they would intersect at A and F. So let's see if we can draw another circle here. So the center of the circle is at 3 and -1. So let's make it about here. Now, F is going to be this point over here. Something important to take a note of is that F has the same y value as n, and A has the same x value as n, meaning that this is going to form a right-angled triangle. So let's just sketch this quickly. So we have this circle, keep in mind, with center M. We have this point A, which has coordinates -1 and -1. We have this point F, which has coordinates, the x value. Let's just have a look. Can we find the x value? So here we know that A is going to have the same x value as n, and it has the same y value as m. So just as A has the same x value as n and the same y value as m, F is going to have the same y value as n and the same x value as m. So the coordinates of F is going to be 3 and 3. So please keep that in mind, okay? So we have the coordinates of F. Let us make a note of this. So it is 3 and 3. So all we are going to do is use the coordinate of A and F to find the midpoint of AF. I'm not going to call it M because M is already a point. I don't want to confuse M, the center of the circle, and M, the midpoint. So I'm just going to call it, let's just call it midpoint. So we are going to substitute. That is then going to be -1 plus 3 over 2 and -1 plus 3 over 2. From here, we can therefore state that the midpoint of AF is 1 and 1. So that is it. That is the midpoint of the line AF. So that is question 4.3.2. All you needed to do was determine the coordinate of F. Once you found the coordinate of F, you just needed to use your midpoint formula and you are done.